Hi friends, this is Vijay here. Welcome to my networking channel. Hope all are doing good. And today the topic I'm going to discuss about auto RP. So in normal scenario, we'll manually define the RP, but in this scenario, it will dynamically auto configure the RP using the feature auto RP. So now there are two things auto RP. One is PIM auto RP and another one is BSR. So auto RP is a Cisco proprietary thing. So there are two things we are going to configure in auto RP. One is a candidate RP and another one is a mapping agent. So in this architecture, R5 and R7 I configured as an RP. So what it does, it will advertise itself as an auto RP via the RP announcement packet. This is a multicast address 224.1.39. So when the mapping agent receives this RP, it will advertise this as an RP to the rest of the router. So that is scenario here. So this is the architecture I'm going to use. So in this architecture, R1, R2, R3, and R4, right? So R1 I'm going to configure as a candidate RP. So this candidate RP will advertise itself as RP via to R2, R3 and R4. So R2, when the mapping agent receives this RP, what happens? This mapping agent function is it will distribute this RP to the rest of the routers. So that is a function of mapping agent. So this mapping agent will send it via 224.0.1.40. So this will advertise via this multicast address, and RP announcement is done via this multicast address 224.0.1.39. So this is the function of PIM Auto RP. So normally in a very big environment or a very complex network, it is very difficult to manually configure the RP address in each and every router. For that reason, what happens? One router will advertise this as a candidate RP. So that it automatically advertises auto RP, and mapping agent asks an R2. When it receives this RP, automatically it will advertise this RP to the rest of the routers. So because R3 and R4 should know which is the auto, which is selected as the auto RP, right? So this is an architecture. Let us now go to the individual router, and this will auto function only in a PIM sparse mode scenario. So first let us define each and every interface and we'll configure the PIM sparse mode. After that, we'll configure the RP announcement and the RP mapping agent. So let us go to the individual router, go to R1 and go to this corresponding fast Ethernet 0 by 0, right? So go here and let us go to fast Ethernet 0 by 0 and let us enable the PIM sparse mode. So always, RP and auto RP will always function in the PIM sparse mode architecture, right? I have defined it. So before that, let us debug the PIM also. Yeah, it is already debugged. So now it is configured on R2 mapping. Faster than 0 by 0 and 0 by 1. Let us enable the PIM sparse mode. Let us go to R2 and go to the configuration mode and interface faster than at 0 by 0. Okay. So interface faster than at 0 by 0. IP PIM sparse mode. And another one is let us go to fast Ethernet 1, right? So let us define IP PIM sparse mode. So that's the thing we have to define IP PIM sparse mode on fast Ethernet 0 by 0 and 0 by 1. I have defined it. So now let us go to the R3. Let us go to R3, go to the configuration mode. Then let us define on fast Ethernet 1 and 1 by 0. So interface fast Ethernet 0 by 1 IP PIM sparse mode, and let us also define it on 1 by 0. 1 by 0 IP PIM sparse mode, right? So after that, what am I going to do? I have to configure only on this corresponding interface for R4. So let us go to R4, go to the configuration mode, interface fast Ethernet 1 by 0 IP PIM sparse mode, right? So this is the thing we have to configure on R1, R2 and R3, R4. So let us quickly check it out. Go to R1, show run interface faster than at 0 by 0. This is the thing you have to configure 12.1 PIM sparse mode. So already defined the interfaces. Let us go to R2, show run interface faster than at 0 by 0. So 12.2, and I configured this as a PIM sparse mode, and faster than at 1. Faster than at 1 also we are configured as a PIM sparse mode. Let us go to R3. Show run interface faster than at 1 by 0, right? 1 by 0 and 0 by 1. So you have defined it. So similar way, let us go define it on R4. Let us go to R4. Show run interface faster than at 1 by 0, right? So we have configured other PIM sparse mode scenario and all these things. So now what is the next step? I'm going to this configure this R1 as a candidate RP. So this will advertise itself as a RP to all the remaining routers. So that how to configure, go to R1, go to the configuration mode, IP, PIM, RP announcement. So it will advertise its announcement. So IP, PIM, send RP is the command. Send RP announce, then we have to define the loopback address. Okay. So the loopback I already defined. Go to the configuration mode, IP, PIM. So IP, PIM, send RP, announce, loopback 0. I already defined the loopback 0. Then we have to define the scope. Scope is the RP announcement scope followed by the interval. So this is a TTL thing. So since it's a small network, I can define the scope as 10, right? So we have configured this as a RP announcement, candidate RP. So there are two things that we have to configure. One, we have to advertise a candidate RP, and R2, we have to configure as a mapping agent. So let us go to R2 and IP, PIM, send RP. So send RP, let us see the discovery thing. So you have to configure this as a discovery mapping agent. So what it does, it will take this RP and it will advertise to this rest of the world, right? IP, PIM, send RP, discovery, loopback 0, scope 10. So that's the thing. Scope, you have to configure the value, enter value 10, right? So this we have configured. So now let us see the, now I have to go, I have to enable the routing protocol OSPF, because for this communication, different network communication, now let us enable the routing protocol. Let us go here. So let us configure a simple thing. Configuration mode, router OSPF 100. So I have to define this network. So this will advertise all the networks. Let us go here and configure. And also let us go to R2. I advertise this routing protocol. And let us configure in R3. Okay. And similar way, let us define it on R4. Yeah. So now you advertise we have the routing protocol. So now let us see the RP thing. Now what we can do, let us go to R1. So what is the command is show IP PIM RP mapping. So you're able to see, right? So what happened? This will be advertised as a auto RP to R2. So this you are able to see. This is showing as an show IP PIM. So it is taking some time. Let us check the routing entries. Show IP route. Yeah, so now it is getting advertised. Now let us see. Show run interface loopback 0. So this we already configured, right? So now let us see the RP mapping. Yeah. So you're able to see, right? So why it took some time means right now we advertise the routing protocols. OSPF took some time to converge. After that, now you are able to see the PIM RP mapping. So what happened? This will advertise itself. This loopback address 1.1.1 I have defined as a RP. So this will advertise this itself as a auto RP to R2. So that's the thing. That is the command we have configured IP PIM send RP announce, right? That means it will advertise its R1 as an RP to R2. So here you are able to see RP address is 1.1. It is selected via auto RP. You are able to see, right? It is selected via auto RP. And now let us go to R2. So R2 also we configure the mapping agent. So now let us see. So immediately it will create a RP mapping. Show IP PIM RP mapping. So now this also R2 also receive. So this you are able to see, right? This is configured as a mapping agent. That's the difference. And R1 it is configured as an auto RP, right? That is the command. That command is IP PIM send RP announcement. And for mapping agent, we'll configure the command IP PIM send RP discovery. That is the only thing we have configured. So now R2, this is configured as a mapping agent. So you are able to see it is selecting this RP 1.1.1. So now what it does, it will take this RP 1.1.RP and it will advertise to this rest of the routers. So let us go to R3 and let us see. Show IP PIM RP mapping. So this also receive this RP address 1.1.1. So what about R4? Let us see R4. Show IP PIM RP mapping. So there is only one issue in this architecture. What is the issue is this R1 will advertise this as auto RP to R2, mapping agent R2 as a mapping agent. When it receives RP, it will advertise to R3, but R3 will not advertise to R4. Why? Because as per the sparse mode, it will not forward anything to the other router unless someone requests for it. So to prevent this sparse mode scenario, what I'm going to do, I'm going to configure a command in R3 IP PIM Auto RP listener. That means what happen once I'm configuring this, then this will advertise this RP to R4. So this command is mandatory in R3. How to do that? Go to R3, go to the configuration mode, IP PIM Auto RP listener. That means the remaining routers will listen to this RP. So that's a command I configured. So immediately you are able to see, right? IP PIM Auto RP listener. So then you can go to R4, you can check it out. So now it should advertise this RP. It will take some time. Let us see. Go to R3 architecture. It's taking some time, right? Let us see. So run fast Ethernet 1/0 and show IP. So let us see the RP mapping. Yeah, so now it received, it took some time, right? After configuring this PIM Auto RP listener, it will advertise this through R4. So now what is the thing? R1 we have configured as an Auto RP 1.1.1. So the entire RP thing, each and every router. So I got this RP information via this Auto RP architecture, right? So that is a function of PIM Auto RP. So we are dynamically discovering the RP via this Auto RP command. So Auto RP, there are two things is mandatory. One is a auto the candidate RP you have to select, and a second thing is a mapping agent. So now let us check the multicast routing table. How to check? Show IP mroute. Yeah. So now you are able to see, right, that the RP address is 1.1.1, and this is the RP announcement IP address. I told it is announced via this multicast address 224.0.1.39, and incoming interface is loopback 0. So outgoing interface you are able to see, right, 1.39. And similar way, let us go to R2 and let us check it out. Show IP mroute. So it also receives this RP 224.0.1.39, and the incoming interface is faster than at 0/0, right? And the RPF neighbor is 192.168.12.1. This is a neighbor, RPF neighbor. Similarly, let us go to R3. R3 show IP mroute. So now you are able to see, right, the mapping agent is advertising via this address 224.0.1.40, right? This is the thing I told, right? Mapping agent will advertise via 224.0.1.40. That is the reason you are seeing here the IP address 224. This is a multicast address for mapping agent. Similar way, let us see R4. Show IP mroute. Same thing, right? 224.0.1.40. So these are the basic things you have to understand about the PIM Auto RP architecture. So one will be elected as a candidate RP, so which will send the packet to the multicast address 224.0.1.39. Another one is a mapping agent. So this function is to take the RP and will advertise to the rest of the routers. So in this specific router, I have to configure the command IP PIM Auto RP listener. So for advertising this RP to R4 also. So these are the key points you have to keep it in mind. So I hope you enjoy this video. Thanks for watching. Please subscribe for more videos. Thanks and have a wonderful day. Thank you.